Hello, everyone. Tim Gavin, Atlantic Testing, area manager here at ATL. I've been doing this job for about 15, going on 16 years. The webinar that we're doing today is Case Studies in Difficult Access for Subsurface Investigation Projects. Essentially, it's a combination of projects that I've project managed where access was a challenge. Some lessons learned on those projects will be shared. Hopefully you'll find it beneficial. It's been a while since I've had to do one of these presentations, so bear with me as we go along. The topics we'll cover are tidal water drilling, deep water drilling, slope access drilling, spillways and dams, wetland, swampy areas, interior building borings, and a neat little project, helicopter access projects. Okay, we'll start off with tidal water drilling. One of the big components of working with tide is knowing what your tide swings are. Is it a 2-foot tide? Is it a 5-foot tide? As you see here on the little diagram, this is a snapshot of the tide swing in the Albany area. We do predominantly our work in and around the Northeast, so we do quite a bit of work in the Hudson River, so that's why I chose this. The tide here swings every 5 feet, and it swings every 6 hours and about 15 minutes. So you'll have a high tide and a low tide during that period. Tidal drilling has its challenges. The biggest challenge with tidal drilling, one of the biggest challenges, is keeping accurate elevations on your boring logs. If you're out in a parking lot doing a soil boring on land, the easiest thing to reference is the ground surface while you're doing that boring. But if you're on a barge and the tide's going up and down and that barge is going up and down with the tide, you can't exactly reference that barge deck. So it's important to reference the mud line when you're doing that on your boring logs, and keep that accurate throughout the day. And using the tide charts is a good way to do that, so you kind of keep track of which direction you're headed. A couple options in tidal water drilling, either using a sectional barge that we operate on, or using a lift boat. In tidal watering, if able to, we prefer to use a lift barge, because that takes the up and down out of the process there. The lift barge is able to lift itself right out of the water as you do the drilling, and you don't have to worry as much about those tide swings going up and down. There are some limitations to using a lift barge. Water depth, obviously. If you're in water deeper than the pipes can reach and push you out of the water, then it's not applicable. We typically subcontract with a firm out of New Jersey, and they can work in 50 to 60 foot of water. Another limitation is the height of those pipes out of the water. So they're kind of limited to where they can get into. If there's any overhead obstructions going down the waterway, they're not able to get there. If you got 80-foot spud sticking out of the ground, you're not going to be able to get under low bridges or power lines and such. You can't pick this barge out of the water, put it on a flatbed tractor trailer, and transport it down the road very easy. So their navigation is all by water. So mobilization, if you're farther from their home port, is long and extensive. It might be weeks to a month before they can get to your project site. And of course it's more expensive using a lift barge than a conventional sectional barge. But the advantage is the stability of the boat. You don't have to worry about tides. You don't have to worry about the wake of the bigger vessels going up and down the waterway, pushing against the boat. It's a little bit of a safer operation and a little more convenient for a drill crew. access using a Spud system. This is what ATL actually owns and operates when we're not subcontracting to use a lift barge. And in this scenario, where we're using these steel I-beams to spud into the subsurface below the mud line. But there's limitations with a spud barge as well, and especially in tidal water. Usually with tidal water, there's decent flows as the tide's coming in or going out. You just think about all that water that's pushing in or flowing out, and you know, it's all coming in 6 hours or so. So there's a lot of flow. So your spud system, you know, has to be robust. We've had trouble over the years spudding in tidal water with you know, having those spuds get damaged. So we typically limit our spud length to about 30 foot of water when we're doing a spud system in a tidal environment. The mudline conditions have to be appropriate. Super soft mudline conditions, the spuds won't bite in, and you'll find yourself drifting with the tide. Stability of the barge is a concern. It's not like drone on the jack-up platform, but it's doable. So our first case study here is a tidal water drilling site down in the lower Hudson. It's actually in the Poughkeepsie area. We were doing geotechnical borings along a side slope. It was actually for a remedial project. Water depths in this area varied from 15 to 20 feet and then fell off very rapidly as you get out farther in the river to 50 to 60 feet. And part of the remedial design was to see what that drop off, what the conditions of that drop off were. If they came in and do any dredging along that, is that slope going to fail? So we were contracted to come out and do soil borings for geotechnical purposes along that slope. Some of the site challenges with this particular project, again, were the tide swings. The Hudson, when the tide was going up and down, it was kind of fearful. So we ended up having to, we started off with a smaller casing and had to go to a larger casing down through the mud line. The 3-inch casing that we were starting off with had a tendency to flex and slap back and forth in our moon hole they were drilling down through the water column with the tide flow. So we ended up double casing the holes, putting an outer casing down so the guys could hook up and disconnect from their drill steel a little bit easier. Water depths were a challenge. Some of the holes were in shallower water that we couldn't get to on low tide where we could get to on high tide. So just, you know, navigating in those shallower water areas with the barge during high tide and not doing it during low tide. This particular project we did in the late fall, early winter. So we added that problem to the mix there. Anytime you're doing work in colder water, you have the tendency, you know, the water temperature might be 40 degrees, but the air temperature is below freezing. As you're putting drill steel in and out of the water, get it out of the water, it tends to freeze. So the guys had to be very careful, putting the steel in and out of the water, and not having their drill steel freeze up and slip on their lifting rings and such. Okay, this was a new project we had down on the Delaware River in New Jersey. The site challenges that we're up against there is the dock that you see here in the picture in the background behind the drill rig was kind of a horseshoe dock. There was no access to the interior portion of that horseshoe from the water side. It was only from the land side. So what we ended up doing was using multiple different rigs to work on this project. We had a barge rig, we had this ATV rig, and we had actually a skid mounted rig that we put out on the dock to do borings. So during low tide events, we were able to mobilize that ATV rig out into the water on the dry land and conduct soil borings there during low tide events. As the tide came in, pull the rig out, and that whole gravel area there would be inundated with water. So we'd move the rig out, and then we'd move to the barge operations, which were on the outside of the dock itself, and do our borings there. So that was the biggest challenge with this job is getting access to that interior area and being able to conduct the work there, and having to do it only during low tide events. Okay, the next section that we were going to talk about here is deep water drilling, and to ATLs, anything over the 30-foot mark is what we consider the deeper water, because that's when we go from the Spud system on our barge to a anchor system. Things that need to be considered is the actual depth of the water. How deep does the water actually get? How long are the anchors going to need to be to get to the bottom? If there's any current involved, and unsupported drill steel. If you're in 70, 80 foot of water, that drill steel will be unsupported across that 70 to 80 foot of water before it reaches the mud line. So the driller has to be very careful in lowering that steel, that they don't lose grip on it and drop at the bottom. You drill a hole in on land, you put your drill steel down, and it's on the ground surface. You lower and drill steel down in 80 foot of water, you lose a grip on that, and it's going to the bottom, and you never get it back. And then the other thing is that the drill steel itself is kind of designed not to be freestanding. It's designed to have some lateral friction to it. So getting the steel straight and down, there's lateral forces on it. It has a tendency to break off in that unsupported water column. Okay, so deep water, like I said, is something that we at ATL classify over 30 feet, and we have to use anchors. We use the Danforth or fluke anchor, as you see pictured over here to the right. Challenges with anchors, you need a lot of area to place the anchors. For a Danforth fluke anchor to be effective, you need, we typically say a minimum of 3 to 1. For every 1 foot of water depth, you need 3 foot lateral to put that anchor out. Some people, require 5 to 1, 7 to 1. If the anchors don't stick, you got to go out further and further until you get them to stick appropriately. So you need a lot of space when you're using anchors. Anchors are physically hazardous. They're heavy, and the Danforth anchors they flex on a joint there, the bottom of those triangles, and they have a tendency to pinch your fingers. When you put a Danforth anchor down, it sticks itself into the mud. That's how it holds. Those triangle forks stick down into the mud, and when you try to pull them up, they're coated in that mud, so that they're somewhat of a physical hazard to release from their position and pull up out of the water. Deep water drilling with anchors, your anchor lines need to be maintained throughout the day. If you're doing deep water drilling in tidal water, we typically require a third person on the barge, and their only job is to maintain those anchors as the tide's coming in or going out. As the tide's coming in and the water level is going up, you need to be letting anchor rope out, and as the tide is going out and the water level is going down, you need to be cinching up the anchor lines to keep the drilling barge stable. Typically on a deep water drilling assignment, you need to have a minimum of 4 anchors out, one on each corner to keep the barge stable. So that needs to be in consideration. knowing that you have that at least that 3-to-1 lateral area to place those anchors out. When that becomes a challenge, and the tidal water drilling that we talked about a little bit earlier, the Poughkeepsie job, there was multiple utility crossings out in the Hudson in that area, and being able to place those anchors without being in conflict with those utility crossings was a bit of a challenge. Okay, the first deep water drilling project here that we're going to highlight was the Goodwill Dam. It was the New York City DEP Goodwill Dam. We were contracted to do borings out into the Goodwill Reservoir. Some of those borings were near the intake structure of the reservoir, and that posed a challenge when we were doing our sediment sampling in 120 foot of water. Our VibraCore sampler was lower down on a cable to the bottom, and it collects the sediment sample, via a core tube type attached to the VibraCore, attached to the cable. So if we had to coordinate with the DEP on their intake to make sure that they weren't taking in large volumes of water while we were doing our sampling and pulling that sediment core barrel into their intake. Doing work for the DEP poses its own challenges, and other reservoirs around the Northeast have similar requirements. All the drilling equipment needed to run on food grade hydraulic fluid to be placed in the reservoir, and so it's not standard to have a drill rig with food grade hydraulic fluid in it. So we had to swap out all our hydraulic fluids, which poses its own challenges. The food grade hydraulic fluid doesn't hold up as well as your standard AW32 hydraulic fluid. Doesn't have the same working temperatures. If it gets hot, it gets real thin, and the hydraulics don't work so well. And as it gets cold, it has a tendency to gel up, and then again, not work as well. So that posed somewhat of a challenge for us. The other challenge was just fluctuating water levels. You get set up on a hole similar to tidal drilling. If they start drawing down the reservoir, the water depth could change upwards of 5 to 10 feet. So as we're anchored, we had to maintain our anchored lines with the changing water elevations and keep them tight the entire time. Okay, the next case study was Onondaga Lake. We were contracted to do the geotech borings out in the deeper waters of the lake, 60 plus feet. This particular project had its challenges with having to triple case the holes. It was an environmental project that had different levels of contamination down through the soils, and the casings had to be we had to put multiple casings down to keep from spreading contamination deeper. The most contaminated sediments were towards the surface, so cased off those sediments and then started drilling with a new casing below that level. Triple cased holes or multiple cased holes poses the challenge of keeping your interior casing from rubbing against your exterior casing. On this particular project, we had somewhat of a challenge. We spun our casing off at least once during the operation. Just the inner casing rubbed against the outer casing and split it off down at the mudline interface. The other challenge we had on this particular project was wind direction changes, similar to your tide changes. Onondaga Lake, if you got the wind coming out of the south or the east, the lake is fairly calm, but as the as the wind changes to the west-northwest, and it can happen rapidly. The lake gets very rough and it pushes against the barge differently. So being out in deeper water, working on the anchors as the wind direction changes, you have to constantly be monitoring your anchors, and the wind might be pushing the barge one direction, and the anchors on that side are tight, and the opposite side loose, and as the wind changes direction, you got to go back and loosen and tighten the anchors in the other direction. Next component we were going to talk about is slope access, limitation safety considerations with doing borings on side slopes, steepness of the slope. A one-to-one slope is not easy to get a drill rig on, and frankly, it's probably impossible for you to get a motorized piece of equipment on. We typically don't like to set up a rig on a slope steeper than a 2-on-1, 2.5-on-1. The length of the slope is important consideration. Typically, when we're doing a boring on a side slope, you need an anchoring point, and that anchoring point is typically always at the top of the slope or along the slope. So if you got a slope that's a couple hundred feet long and your anchor's at the top, you need a winch cable that's at least that long to connect to it, to your anchoring point to do the job. So it's important to know the length of the slope, and what to use for anchor points, whether it's a large tree, a dozer, or an excavator that's positioned at the top of that slope. Rig capabilities is important. Very important lesson learned that I learned early on in my career. We had a CME-45 drill rig that we could set up on a side slope similar to this 850 track rig. Has what we call angle hole capability. So the rig itself could be positioned on the side slope at an angle, but the tower could be put in a vertical position, and you could drill a vertical borehole. So put that 45 on the side slope, knowing that it had the angle hole capabilities, and the guys started to advance their boring. Well, shortly after they started to advance the boring, the motor started knocking on the drill rig, and before all said and done, they'd blown the engine on the drill rig. So we didn't know exactly what had happened, what had caused it. Doing a root cause analysis, we determined that the oil intake on the engine was on the top side of the oil pan, and with the rig being on the side slope, all the oil had kind of went to the bottom, and it wasn't able to lift up into the intake. So just because the drill rig had the angle hole capabilities didn't mean that it was designed to work on the side slope. So something I learned early on, and had to have an engine rebuilt on a drill rig. So as you're scoping out projects on side slopes, it's good to make sure that the drilling firm knows what the capability of their machine is, and it plans for that accordingly. So our first case study here is Vermont cell tower sites. We've done quite a few of these over the years. The challenges with these sites are, unfortunately, they're usually done during the winter months, and tracking the drill rig up these side slopes during the winter. Usually the sites are login trails that were used at one point in time for logging, or a lot of times maple syrup trails as well. They're usually narrow and curvy. So the drill rig has difficulty. The track drill rigs have difficulty climbing these narrow, windy access roads. The cleats don't bite into the soil so good when it's frozen, and just the depth of the snow also poses a problem. Typically, the Vermont mountains rock's fairly shallow, and the main purpose of getting to the top to do the boring for the cell tower is determine the quality of the rock to put the cell tower on. So, you know, typical drilling requires water to core with, but transporting water up those side slopes is near impossible. So, in this case, we had to mobilize air compressors up with our drill rigs to do the coring and to clean the holes with air versus water. This project was a geotechnical project on a side slope in a railroad in central New York. Did geotechnical borings and CP soundings for the slope analysis along the railroad. The challenge with this project was it was already a failing slope, and they needed borings and inclinometers installed along that slope. So placing our drill rig on that slope that was already failing was, somewhat problematic. We had to make sure that we had good anchor points and such. We did have a near miss on the project. The guys had a drill rig set up. It was jacked up. They were conducting their boring, and the slope did move a little bit, and the cribbing came out from underneath one of the jacks, and the rig tipped. The rig didn't tip a great distance, but it could have. So, the lesson learned that we had on that project was when we're doing work on the side slopes, we don't let the guys jack the rig up off the tracks. They stay right down on the drill rig tracks and just jack up enough to keep the rig stable. The next project we had was another railroad project that we were doing in the Glens Falls area. We haven't done this in quite a while, but this project required us to build platforms on the opposite side of the track. The site challenges there were the actual construction of the platforms to place our skid rigs on. Required the use of a crane set up on the side of the track in coordination with the railroad company to be able to place the skid rig on the cribbing up over the track with a crane. Important with setting up your cribbing is you bench it into the slope enough and make sure that the cribbing is stable, so when you're drilling, it doesn't come loose. I think the last one here under our slope access case studies is a project we did in central New York, Syracuse area. Again, doing geotechnical and soil borings and installing inclinometers along the slope. This particular project was fairly slippery. Getting the drill rig up into, we actually lost traction with the drill rig and it slipped. So it was very important that we had, a rated winch cable on the drill rig. We had an anchor at the top, a bulldozer as our anchor at the top. It was important that the bulldozer was heavy enough to support the drill rig, and that the winch cable was also strong enough to support the drill rig, because as we were coming up the slope, the tracks lost traction, and essentially the only thing that was keeping the rig from sliding was that winch cable and that anchor at the top. It didn't have any resistance on the tracks. The other challenge that we encountered that we didn't think about when we started this project was we came up from the bottom to get onto the slope. The anchor was at the top, but the drill rig came up from the bottom to conduct the boring. We were installing inclinometers, stick-up inclinometers, so they were sticking up out of the ground 3 feet. When we were all said and done, we got the first one in, and then we had to figure out how to get the drill rig out and around that inclinometer that was just installed without backing over top of it. So that posed a challenge with the first one. But after that, we decided to leave the surface protection off until we backed the drill rig up over the top of the inclinometer and we're able to continue on successfully with the rest of the project. The next challenge that we wanted to touch on was spillways and dam drilling. Limitations, safety considerations with the spillway and dams is the actual size of the dam and spillway. If you're doing borings on top, standard drill rig is 6 to 8 feet wide. Can you traverse that top with a drill rig that size? Doing water along a spillway or dam that has water flowing over it, considering dropping the water level down if that's feasible. Dam construction and dam intake structures. Dam construction, a lot of your earthen dams have riprap similar to this picture here. It's one of the most challenging drilling material to go through. It tends to bounce around as you try to drill through it. So knowing how the dam is constructed is very important, and what the challenges are going to be associated with trying to get through that construction. Our first case study was the new Croton Dam. It was a geotech investigation of the spillway of the new Croton Dam. This particular case, we had to build a special platform that came off the front of our barge, the cantilever off the front of our barge, to be able to drill down through the spillway itself. The safety considerations on this project, the water depths on the backside of that within the reservoir were deep, 50 to 60 feet, so we weren't able to spud in. So we ended up having to put anchors into the spillway itself and tie off to the spillway to keep us from moving back and forth. We also we did put spuds in the barge and put them down. So there was the steel pipes that went down 10 feet below the barge deck in case the water elevation rose and the barge wouldn't go up and spill over the dam. Again, coordination with DEP was a challenge, making sure we had the hydraulic fluid in the drill rig and such. And just positioning the drill rig was a bit of a challenge with the water flowing over the dam, getting it positioned and trying to keep it straight without it trying to turn sideways on you as you're coming up to the slope. Okay, the next project I'm talking about was the Keogan Dam project. This project was a small dam in Keogan, New York. The challenge there that we had is getting the equipment to the dam itself. We weren't able to use a barge because of low bridges and such. We couldn't get up underneath them. We ended up having to use a john boat to get access to the barge. With that being said, we had to use some of our portable equipment and set the portable equipment up on the dam spillway itself. Using the portable equipment, we call it our long ear 65 pneumatic drill. It gets anchored down into the spillway itself, and it's air powered. Safety consideration with the long ear is it spins really fast. So the guys working on top of the dam without railings or without the fall protection, we had to come up with a railing system for them to work on. Having a tie-off rope system wasn't what we felt in our best interest. If the guy's working around that drill rig spinning at the speeds that it spins, having a rope get caught up in that would pull them into the drill rig and cause major safety concerns. So this particular project, we had to come up with our own railing system to install on the spillway, and to mount our rig on it and work off it safely. So the water depth consideration was, essentially couldn't get a boat up underneath the bridge, low clearance bridge, with the depth of water and the height of the bridge. The next project we were looking to highlight here was the Nipigon Dam, just downstream from the Keogan Dam. The challenge with this project was the actual height of the dam, having enough cable to reach the anchor at the top, and the dam construction itself. The earthen dam was made primarily out of glacial till, and advancing the casing down to that till was problematic. For the height consideration, we ended up having to use two different cables, one cable attached to the excavator at the top, and then the actual winch cable coming off the drill rig. The winch on the drill rig didn't have the capacity to do it in one shot, so tie off two different cables to get the drill rig into position. We also, I failed to mention this earlier, when the guys are set up, working behind the drill rig, we also required them to attach a secondary safety cable in case the first cable was to fail. That way, the drill rig is never unsupported on that anchor point and doesn't have the possibility to slide back against the guys as they're working behind the machine. Okay, our next topic was wetland, swampy area drilling. As you see the picture, don't do this. This was actually a project we did here locally, fortunately for us. Didn't appear to be all that wet when we started out. Went in to do the boring, finished it, had no problems getting in, and then went to get out of the location and buried our 850 drill rig. Which posed problems. That machine's, a 25 to 30,000 pound machine. It just spun on its tracks, and as you spun the tracks, it just kept on getting deeper and deeper. So fortunately for us, it was a local project and we had local resources. So we had to mobilize a very heavy payloader to come yank that machine out of that mess that it created. What ended up happening was when the rig went in, there was a good root mass that it got traction on and supported itself going into the location. And then it kind of broke that root mass up in heading into that site. And then when it came back, that root mass still wasn't there anymore, and the machine sank out of sight. But limitations, safety considerations when doing work in wetlands, obviously permitting requirements, what's required by the DEC, what kind of erosion control do you need to do, soil composition. Like I said, in this situation, the surface seemed good when you were standing on that root mass, but as soon as you broke up that root mass, the soils went to crap, and we sank the machine. Cost with getting into these remote wetland areas, if you're talking about placing wooden crane mats, that is a very large cost that has to be consideration. So some options in wetlands versus mobilizing the large drilling equipment, similar to the 850 that we had buried, is tripod hand sampling. Tripod hand sampling has its limitations on boring depths. Hand sampling, you can only go as far as you can physically drive that sampler. Typically, we like to say 10 to 15 feet is the max you can go hand sampling. Tripod, the same. Drilling conditions, anytime you're using hand sampling or tripod, the equipment to advance a borehole, you don't have the ability to spin a casing or spin a rock core through that material. So if you hit cobbles and boulders, you're kind of in trouble. You have very little ability to break up or cut through that cobble or boulder. So you're going to need the right drilling conditions to be able to advance your hole in those conditions. hand sampling and tripod work takes a considerable amount of time to do. It's not, you don't have the mechanical means to advance that borehole. So you're talking 2 to 3 times longer to advance a hole than you would with conventional means. And I already mentioned the lack of the ability to core rock. There isn't a hand core to be able to core rock. Project that we're highlighting here on the wetland swampy area sites is a lagoon sampling event that we did in northern New York. The challenge there was sampling from a john boat in the lagoon. We did this project over a couple different phases. The one phase was from a john boat. And the difficulty from sampling from a john boat, there's no good anchoring system. As you're hand sampling, the boat moves around, a little bit, and being able to hold on to that sampling equipment as you're advancing it is a bit of a challenge as it's moving around. The second phase of this project was drilling during the winter, which allowed us to mobilize our track rigs. The wetland area itself had frozen over, and with the ice, we were able to mobilize the track rig out onto it and much more efficiently do the soil borings. So as you're considering doing work in wetland areas, time of year is important. Try not to do the work during the wetter periods of time where there's the most standing water. Preferably do them during the winter periods of time, because there's potential you could mobilize your conventional drill rig out there to conduct the borings if the wetlands are able to freeze over. The next project we were highlighting was our Hudson River walking trail project. This was on the Champlain Canal. There was no land access to the locations. In this case, the drill rig had to be mobilized from a barge. Put the 850 out on a barge and brought it into shore. Along the shoreline, it was very soft, so the shoreline had to be matted to get back into the boring locations. It was kind of a really neat project. The first time we had to unload a drill rig from a barge. We had to consider the weight distribution as the drill rig was coming off the barge. If you put all the weight towards the front of the barge, it submerges the front of the barge and then lifts us back of the barge. So we ended up having to ballast the barge out with some water in the rear while we were loading and unloading. Next project was our Massachusetts transmission line upgrade project, doing soil borings along a transmission line. Extensive wetlands involved. Project required the use of crane mats to get in and out of the boring locations, as you see pictured here. The challenge with using the crane mats to get in and out is the length of time that it takes to place the mats, and the cost is associated with that. When you get into using the crane mats, it drastically increases the cost of the project. We purchased some mats, but we've learned, our lesson learned there is that there's professionals that do it every day, and it's best to contract directly with somebody that places mats on a regular basis. The other challenge with crane mats is following the appropriate permitting process, the cleaning of the mats between locations and such. Next consideration for difficult access is interior building work. seeing the need to do work inside buildings more and more these days as equipment gets upgraded and such, needing borings within those spaces. Considerations there is how do you get the equipment into the building, what there is for overhead clearances, what kind of floor compositions, what do you do? Most drilling equipment is gasoline or diesel powered. What do you do with the exhaust from that equipment? How do you handle dust generated in the drilling process? Utilities, and sometimes working within confined spaces. First project we want to talk about here is our Robert Moses Power Dam. Required to do borings within the galleyway of the power dam. Site challenges there. It's a very large dam. Getting the equipment down into the dam itself was a bit of a challenge. Again, we used our pneumatic portable drill rig for that. Getting the air hoses down to run that drill rig was a challenge because of the length of the run to get the hoses there. Dust control and water control was a problem. There was relief wells within the dam, so we had to be careful not to silt in those relief wells with our drilling water. And just the location of the holes was a bit of a challenge. Next one was a manufacturing facility that we had to do borings within. This particular project, we didn't do our homework on the front end of things. Our plan was to skid in one of our 45 drill rigs on its skids in the position to do the borings. When we arrived on site and looked at the floor, we determined that the floor was a relatively new polished floor, and skidding the 45 across that floor would have gouged and left some markings across that floor. We ended up having to get rollers for the 45 itself and put it up on the rollers to position the drill rig where it needed to be. Another problem with that particular project was the length that we had to pipe the exhaust outside. I think we ended up having to purchase a exhaust fan within the exhaust pipe fan to make sure that the exhaust made it all the way to the outside and didn't snuff out the drill rig. One thing that we require when we're doing interior work with a combustible engine is to monitor the air around the drill rig to make sure that all those fumes are being exhausted outside, and to make sure that we're not posing a hazard to any of the occupants of the building with the exhaust. This particular project, we're doing interior borings in an old chain store. It had been abandoned for some time. Consideration there was the lack of power, so providing portable power, testing the floor material. One of our policies at ATL here is we don't put anything through an interior floor without it having a hazardous materials assessment done prior to conducting the boring. We don't core through floor tiles for the potential of asbestos material. So this particular project, there had to be an asbestos abatement done at each one of the boring locations before we conducted our work. And as you can see, the mold was also an issue here. So the guys had to make sure that they had appropriate respirators to mitigate the mold problem. Okay, so our next topic here is helicopter access. This is a unique project that we did, so figured we would talk about it here as well. It's a one-time type of project. things we had to consider was helicopter safety. We don't deal with it every day. Enlisting a professional to make sure that we knew what we were doing, working around a helicopter. Make sure that the lifting of the equipment was appropriate, setting up a landing zone, making sure we knew where the equipment was going to be positioned, when we were doing our work, how we were going to get it into the landing zone. And the helicopter access, by its definition, is remote access work. So the other thing we had to consider is, so we're doing work in remote access, that's helicopter access only. How, if there's an emergency, how are we getting emergency personnel to us to help assist us? So we had to consider that. When we're scoping out the project, communicating with the local, fire rescue departments, DEC, on what they could do for us if in the event of an emergency. The project itself was in Lake George on top of Black Mountain. Project was actually for a state police communications tower, so in communications with the local law enforcement and the fire departments was a little bit easier because it was for the state police in the end. The site challenges, obviously it was remote. The conditions, we used our long ear portable drill rig again for this operation. That long ear runs off an air compressor. We typically run a 400-200 air compressor to run that machine. But in this case, the 400-200 air compressor was too heavy to lift with a helicopter, so we ended up having to split and use 185 air compressors and manifold them together to operate the drill rig. The guys flew up to the top of the mountain with the helicopter and camped out 5 days on top of the mountain. So, considerations on what we're going to do with the drillers, make sure they had ample supplies for that. Look at the weather. We didn't want them to get trapped up on the mountain in adverse weather. So those were all things that we considered when scoping out this project. All right. Just about to the end here, Lindsay.
All righty, here's question 1.
So question 1, what is the limitations using lift boat for borehole access? D, all of the above.
Are we ready for question 2?
Yep.
Here we are.
Okay, question 2, you typically don't have to adjust anchors when they're set in tidal water. That would be false. You always have to keep the anchors tight, and as the tide's going in and out, keep adjusting them with the tide swings.
All right, question 3.
Okay, question 3, all drill rigs are designed to operate on side slopes. True or false? False. Not all drill rigs are designed to drill on side slopes, as I found out with our CME 45.
Question 4.
Hazardous material survey should be conducted prior to coring floor tiles when working inside of a building. True. You don't want to have the asbestos guys be over you for spreading asbestos through a building. So make sure the hazardous material survey is done before you impact material.
Final question.
True or false? Helicopters have unlimited capacity to move equipment, and that's hopefully pretty self-explanatory. That's false.
Alrighty. Tim, are you ready for some questions from the audience?
I guess so.
Alrighty. Our first one was from Gary Garapal, and he said, hi, what are some of the changes to hazards and safety when clearing a drill hole with air versus water?
Well, from my experience, when guessing you're talking about looking the first 5 feet, looking for utility, making sure that there's no utilities in the upper 5 feet of a boring, and clearing the hole prior to putting drill steel in the ground. Challenge with doing that, I guess we didn't really talk about that in this presentation. Well, now that I'm thinking about it, you're talking about coring with air versus water, which was in the presentation. So the challenges there, what we found, water is a better lubricant for our drill bit. So when we're using air instead of water, we have a tendency to heat up the bit. We get a lot more wear on our drill bits, especially in sandstone. We got a couple of bits here that we thought were pretty neat, where it actually the sandstone grooved the drill bits when we were using air versus water. Also have, as you're using air instead of water, inhalation hazard as the air cuttings are coming out of the hole. There's big push with silica and inhaling silica dust. So having appropriate precautions in place to limit that. But all in all, water is preferred choice of a driller versus air. It better lubricates the bit. You get better wear out of your drill bits. Sorry about that. It took me a second there to figure out what you were asking.
All right, we've got another question from Thomas. He said, what types of track rigs do you use for side slope work? Mobile, CME, Acker?
So ATLs, it's pretty much exclusively of CMEs. So we use CME 850 when we're doing work on a side slope, and the 850 itself is designed to work on a 2-to-1 slope, and it has very good functionality when it comes to operating on a side slope.
All right, next question comes from Andre. And the question is, do you have to plug the drill holes in a dam?
Yes. You should probably grout your drill hole.
And the next question from the same person, do you use subsurface investigations other than drilling?
Yes. We do CPT, cone penetration testing. We do not do GPR in-house. We do soil resistivity testing in-house. Sediment sampling using VibraCore. That's about it.
All right, we had a question from Timothy. He said, did question 1 say what is one limitation? And yes, it did.
True. Sorry about that.
All right, I'll give everyone a moment for any last minute questions to come in. All righty, I'll take that silence to mean there are no more questions. Was there anything else from you, Tim?
That is it.
All